Now it's like,
Okay.
hi everyone, this is the original Scary Ammi, and I'm back with Kim Langen after a really long time. Well, it feels like a really long time because we were so regular with doing them, but it wasn't that long. I think we just took off for Kim's like Christmas break and New Year's break. So for those of you who are joining us now, and let me just refresh your memory. So Kim Langen is the CEO of Spirit of Maths. She's based in Canada and she's a global educationist. She has a lot of exposure and experience on how education is changing around the world. And we've spoken a lot about how education is changing in this COVID and hopefully post-COVID era. So, and Kim regularly does sessions with us so that the mothers in Pakistan can be just as equipped and informed as mothers all over the world. So today we're focusing on what is probably Kim's favorite topic, maths and how to teach maths. And we've spoken about it a lot, Kim, about how you feel that maths teaching around the world still lacks a lot. So today's topic is mental maths and how mental maths teaching can be improved, what strategies you can use to teach your child better mental maths. So I am super excited about this one because I really want my kids to be like those Guinness Book of World Record wizards who just like shooting numbers out. And I've seen a lot of Indian kids do that. I don't know if it's something to do with the way Indians are being taught, but apparently these Indian kids are amazing at spelling and amazing at mental maths. So hi, Kim, and so excited to have you delve into this topic.
Thanks. Okay. Well, this is, it's interesting you mentioned the Indian because they certainly do encourage a lot of memorization. And so and they also, for the math, they encourage Vedic math, which is sort of little tricks on how to put the numbers together. And so it makes them look really good that because it appears that they can they can add up a lot of numbers, big numbers, but it's not necessarily that you can do all the other math, because arithmetic is different from mathematics. And I just wanted you to, or it's part of mathematics, but it's not all of mathematics. And with this mental math, I know a lot of people, they're, it's an important part. It's not critical that you can add big numbers, and it doesn't mean that you're going to be a better mathematician. However, it certainly helps to have some foundational ideas in mental math so that you understand, so you've got some fluency and automaticity, and then also so that you can understand how numbers work with patterning and so on. There's, so when you're mentioning that, that's okay, but it doesn't impress me much when I see them adding all big numbers. No, it doesn't. What I think is more important is that kids can do the basic numbers. They can get those basic calculations. They know how the numbers work. The other thing that doesn't impress me is when people are using their fingers and say, oh, I can add, and I can do all this stuff using my fingers, and now I've done mental math. Actually, that's not mental math. These are manipulatives. And you're using manipulatives, a different type, and you're not actually seeing how numbers work together. And so when I'm talking about mental math, I'm going to be like, I could go over a lot of different little tricks, but I'm not going to do all of that. I want you to start looking or think about this in the most basic foundational way, where it's, what are the patterns? What's going on, so that you can remember some things and do some things. So I don't know if you wanted to talk a little bit more about mental math before I go into it, or...
Yes, like, can you explain, when we talk about mental maths, very simply put, is the ability to add, subtract, multiply, divide in your head. Is that what mental maths is?
Yes. And it could be that sometimes it could be a long calculation that's in front of you, and you're able to like add and subtract and multiply everything in your head by looking at that. So it's not necessarily that you're only just hearing it. It is also the fact that you can actually see it and then do it in your head. Does that make sense? So like, for example, at the end of class, for our exit ticket, so to speak, for the class to be able to exit, one child out of the class has to be able to answer an oral mental math. And for us, an oral mental math would be something like, 10 plus 10 minus 10 plus 2 minus 3 plus 1 plus 10 plus 1 divided by 7, and add 2, multiply that by 5 and add 1 divided by 2, and see if you can get that answer. And so one of the kids in the class could be able to get that answer, and you don't do an order of operations, it's just what you're hearing, and you do it in order of what it's being said so that you actually have the answer at the end. So I think, what it is can you actually manipulate those numbers in your head? And that's what's important. So when we go to that, and then you want to go to the next level, because if you're able to manipulate those numbers in your head and be able to see things, your mind is actually calculating when you're doing mathematics without even realizing you're calculating. But if you can't do that and you're trying to look at a math question, you're going to be stuck on basic calculations. So for mental math, think about it this way, because you said, oh yeah, I want my kid to be able to do this big one. Well, you know what? Even if they can do one like this, that's what's going to get them going. So in fact, that's kind of more important than this. Some of our brightest students, when I say bright, I mean top of the world students,
Wow.
are the strongest in mental math.
Are not the strongest.
Right.
Oh.
So this is why I'm saying it's important you've got some, like, have this. You don't need the huge amount of ability to do all this mental math to be strong in mathematics. Okay, so because mathematics is about ideas that are represented using numbers, and you can manipulate those ideas because you understand how numbers work. But when it gets to a certain point, really, like, it's better to concentrate on the ideas and let the calculator do the huge calculations. That allows you to free up to the bigger ideas. But if you don't even know 3 times 2,
Yeah.
that's a problem.
But do you feel all this emphasis on mental maths in schools and all, is it like a thing of the past? Do children not need to know tables till 20 into 20, I think is the level at which they need to know at HSN, like 19 into 19, like they need to go to that level. Is that no longer needed? Because I've often wondered that, just like I wonder if spellings are needed because you have spell check now. Is mental maths needed because you have calculators? So isn't the application more important, or the sentence structure more important in terms of English rather than spellings and mental maths?
Okay, so there's a couple of things here. First of all, they believed that, and what happened was I'm going to say they, because people who were bringing out the policies or putting out the policies for everybody, who wrote it and said, now this is what you're going to do, they actually, there was a huge movement that said you don't need to know any of these calculations. And they said it's because we have to get to these bigger ideas. Now, there's a problem with that concept, and they realized it years later when all these kids were graduating. And that was that they couldn't even do the simple calculations. So when you were just discussing things and doing some simple things, they couldn't even, they couldn't enter in because they were still stuck on, what's that, 3 times 6? And oh, okay, that's 18. And then they would be behind everybody else, behind the conversation. And it was actually a very critical, it was a very dangerous decision to say they didn't need to know. And people at the top of, who are really at positions in globally, who are making these decisions, actually admitted we made a big mistake. Kids do need to know some fluency. They have to have some fluency. And so, in fact, even in Ontario, in our province here in Canada, they just brought in a whole new math curriculum last fall. And in that math curriculum, they said kids have to know their math facts now. And before that, they were saying not at all. They shouldn't be spending any time. In fact, teachers got in trouble if they spent any time teaching and ensuring the kids had the fluency of number facts. And now they brought it back because they realized the necessity of it and the ramifications of these people not having it. And I see it even as a business owner. You can tell when people don't have even the basics in some mental math, because you're discussing some numbers, or you're going through some financial statements, or you're looking at some KPIs that people are working on, or you're just even some basic numbers, like when you're talking about COVID, and you're talking about, well, what's the percentage of this and that, and you can see they're clouding over. They're trying to pretend that they know what's going on, but they're not even able to enter in. And so it's really putting them in a disadvantage. So some mental math is important. It's not that you need these big numbers. Like Aitchison's decided 19 by 19, or 19 times 19. And that, okay, that's fine. So then 20 times 20. But that's fine if that's where they want to go to, because that's a little bit more than the average, but it's not crazy. Okay, so that's, again, like when I'm saying, if you could give a kid a 7-digit times a 7-digit number, and they can multiply that in their head because they know all these tricks and this Vedic math, and you can do, or whatever you're doing. Okay, it looks impressive. It's sort of like a party trick, but that's about it. Okay, and so I wouldn't worry. I would spend more time on ensuring they've got the foundations, like the basics for calculation, and then go from there. With spelling, because we have Spirit of English too, those kids who don't know how to spell really are challenged. They are challenged. And just trying to it's really frustrating for them too, just trying to get ideas out, because they get stuck on words. They don't know what to put. People don't know how to read what they're writing. And even if you've got spell check, it's still, it is saying it's not important to understand where words came from. And for spelling, it is critical. This is a language, and words are spelled a certain way because they've come from somewhere. And so that understanding is important, and for kids to understand that words have come from something and a meaning, makes it much more meaningful. And so spelling isn't just about can you do it or can't you. It's about understanding the value and where words have come from. So I don't know. There you go. There's my 2 cents.
Okay, makes sense. So, Kim, do you have a PowerPoint that you want to share? And then, because we have a lot of questions piling up, but
Okay.
we can get to them after you were going to run through some basics.
Yeah. Okay. So let's go to, I'm just going to do a couple of real basics in this one, and then we can go to another one. We'll do this in a couple of sessions. Okay. So with this, what I thought I'd do is just start with some real foundations for young children, and even for some older children that I'm finding don't even know these foundations. So let's start with that, and then we're going to get you to do some mental math as well. Okay? So we're going to use you.
Let's hope I don't embarrass myself, but
no, that's okay. All right. So for this one, I'm going to just start with this foundation. They're called number complements. And numbers that complete or bring to perfection. Basically, a complement are things that complete or bring to perfection. And I put perfection in quotes because for numbers, what is perfection? Well, it's kind of hard to define. Well, they do have something called perfect numbers, but that's a whole nother topic. So I took this right out of the dictionary. Not the numbers part, but things that complete or bring to perfection. So for numbers, it would be numbers. Let's substitute things with the word number. So in this case, perfection would mean something or to what we want to get to. So in the first case with young children, we start to numbers that complement each other to get to 10, to create the number 10. And so when kids have that concept of 10, or that 10 is important to begin with. This is really critical, because if they don't even start with that and know that the value of 10, then they're lost. And it's this 10 is is key. So from there, you introduce to the kids, well, if we know what makes 10, and the reason why 10 is key is because we work in base 10 numbers. And so everything is easy if you can go up to a base 10. So we start with the young children with 1 plus 9 equals 10, and then 2 plus 8 equals 10. And then we do 3 plus 7, and then a 4 plus 6. I know that you all know you're getting this. And then a 5 plus 5. And then they have to see that there is a pattern. Well, then what are the patterns? So at the same time as teaching them what is the complement of each of these, they can also see that there is a pattern with this whole complement to 10. And so right away for mental math, if kids are able to see the patterns, they're able to then do more mentally. Okay, so it's not just teaching facts, it's teaching identification and the ability to discern these patterns. So you can see very quickly there's a couple of patterns here. Can you name one pattern? And I usually ask the kids this too.
That the numbers are going up by 1, and then that would be one pattern, right? So it's 1, 2, 3, 4, 5.
Yes, okay. And so you've got that pattern. And now what's another one?
That they're going down by 1 also. So 9, 8, 7, 6, 5.
Yeah, okay. So or it's going up, going up, right?
Did I get it?
That's excellent. Okay, so if you've got that, then fabulous. Okay, so what what I think is important now is that when kids see that, then there is a pattern. For some reason, my stylus isn't working, so I'm just going to highlight maybe. Okay, so when they see that, then they then know that they can memorize it a little easier. So when you say 1, 9, 2, 8, 3, 7, 4, 6, 5, 5, and you notice the anchor is on the 1, 2, 3, 4, 5. And then they automatically, when you get them to memorize 1, 9, 2, 8, 3, 7, 4, 6, 5, 5, then when you give them the 1, then they can say very quickly 9. And if I gave 2, they should say 8. 3, 7, 4, 6, 5, 5. You show them, of course, first why this works. It's not just memory. It's you have 10 objects. Put one off to the side, you have 9 left over here. Oh, if you take another one over on this side, you have 2 and you're left with 8. And so the idea too is that you're always equal to 10. The total is always 10 though. So that conservation of numbers is really critical. So they understand how numbers work and they can remember then these numbers. So once they remember those numbers, so if I said to you, if I gave them a 1 and I wanted to make 10, then I would just say what goes with 1 to make 10, and they would know 9 right away. From there, then I can say, well, what goes with 9 to make 10? Well, 1. Well, what if I take away 9 from 10? Well, it's 1.
1,
Okay.
yeah.
Because 1 and 9 always pair together. They're complements. They complement each other to come up with 10. Always, always, always. So you can say 10 minus 1 is 9. 10 minus 9 is 1, and 1 plus 9 is 10. So you spend some time with the kids at a very young age. In this kindergarten, you can start this at, if not even before. There's no reason why they shouldn't have those memorized at that age. So then when you do that, then once they have that, I'm just going to add something on here. And if you wrote this and then, then, so when they've got that, then they can do, well, you also teach them to count by tens. So if you teach them to count by tens and you get them to see, well, what's going on here? If this is counting by tens, what is the pattern you see here? So what pattern do you see, Ayesha?
That they're increasing by 10.
Okay.
Right? 10.
Well, so if you're a young child, and this is good that you're saying, okay, they're increasing by 10, they won't necessarily say it's increasing by 10. They won't know that concept necessarily, but they will see a pattern in here. What's a basic pattern? If they know how to count, what's a basic pattern they will see?
That it's 1, 2, 3, 4, 5, 6, 7.
Yes. Okay, yeah, thank you. And so, and I guess part of it is going back to, even realizing, oh, we have to go back that step. So, okay, it's 1, 2, 3, 4, 5, 6, 7. And what else is the other pattern? There's one other pattern that's happening here.
That the is that a pattern? That the zero is staying the same. Is that a pattern or no?
Yes, yeah, it actually is because the fact that that zero is staying the same is huge. It's a huge importance. So, so don't just assume that the kids will see that. Okay, when you're starting, and like I said, this is part 1 of mental math, and it is even for you as an adult to learn how to see what's in front of you that seems obvious, because some of these obvious things will help you later with much more complex ideas. And if you miss those and think they're not important, then you could be missing something that is critical for some higher level understanding. So with this, then the kids can learn very quickly 10, 20, 30, 40, 50, 60, 70. All right, so when they know that, if I said 20, what's the next 10 that comes after that?
30.
Okay, if I said 50, what's the next 10?
60.
If I said 70, what's the next 10?
80.
Yes, okay. So now if you know
Does it
that,
help when you're teaching this to children? Does it help to put it in front of them visually, like write or use flashcards, or is it better to just make them think mentally? Like, does it help to have it there, like visually in front of them,
oh, for
like
sure.
you put it, like visually in front of them?
Yes. So actually, thank you, because I'll show you a little activity or exercise that you can do with kids so that they have to start with, first of all, manipulatives. You start with that to explain why. Then you can get to the visuals, which is I've shown here. And then you get to the mentally so that they don't even have to see the visuals. Because we work visually. Humans work with our senses, and that's how we process. So part of that's why the manipulatives start, because they actually are touching and they're seeing. And then you turn it to the symbols, which is what I've got here. And then once they see the symbols, then you want them to memorize. So at this stage, before they, you know, and I'll talk about then yeah. So let's just do this part. So with this stage, what you want to do then is you'll say, okay, so here's 1928374655, and you get the kids to say this with you. So you actually will highlight and you will point to the numbers, and all the kids will say 1 and then 9, 2, 8, 3, and you point to each one as you go. So if I was saying 1, then the kids would say 1 with me, then 9, 2, 8, 3, 7, 4, 6, 5, 5. Then what I would do is I would start to take away a number. So, whoops, I may go like that. And now they have to repeat it. 1, 9, 2, and they have to say the 8 without me. 3, 7, 4, 6, 5, 5. And then I would take away another one, for example, that one. And they'd start choosing the numbers that they would take away. And so from there, what you've got is you've got them starting to memorize bit by bit without without really realizing that they're memorizing a lot at once. But by the end, really what they've got here is that. And they'll be able to say 1, 9, 2, 8, 3, 7, 4, 6, 5, 5. Okay, now why is that important? Because then when you start to put a bunch of numbers together, and if I said to you, what's 1 plus 9 plus 2 plus 8 plus 3 plus 7, they start seeing, well, that's 30, because I know those are all combinations of tens. And now I can start counting by tens. And you can count up and down from tens. So I could say to you then 1 plus 9 plus 2 plus 8 minus 3 minus 7. And now you're back at 10. So you can see how you move up. So 1 plus 9 is 10, plus 2 plus 8 is 20, minus 3 minus 7, we're back at 10. So you're just starting the kids, and this is really the beginning. And for the kids to understand how numbers combine together to create something that is easy to work with. And this is really the foundation. If they don't have that understanding, you can't even get onto any other mental math. So should we take up some questions now, and at least, and then, we'll see how much further I can get after that. I just don't want to lose the time for all these questions that are coming in.
Sure. So we have a question from Faiza Ali, who's saying that, she has a 7-year-old and she wants to know that with 7-year-olds, how do you start mental maths? Like, her child is good in maths, but she wants to know, how does she bring about an interest and a skill in mental maths?
Well, you start with things like that exercise I just told you. We always make sure even when we're starting with kids at an older age, we always go back to this idea. Because you think it's obvious, but it's actually not to kids. It's not that obvious, that even some basics like that. Because once they've got that, then you add on to it. Kids only feel successful they only feel that something is meaningful if they are successful in it. And so if you just jump up and say, well, I want you to now get to 23 times 3 really fast in your head, if they don't even know some of the basics, that would be multiplication basics. But if you're asking them to add a bunch of numbers together, or even like, what's 40 minus 26? And you want them to do that in their head. If they don't even know how to go from 26 up to 40, and they don't even know that you can go up to 30 and then have another 10, it's very tough for them. So I would start with these basic idea, just get to 10s to begin with, then you add on. So if you did 2 plus 8, now you could do 12 plus 8, you could do 22 plus 8, and you can do 132 plus 8. And then you could do 132 plus 18. And then it's all the same ideas, but they are building it up. And now they've got the basics, and now you can add, and you can add on to it. And then you can start doing subtraction with it. So they're seeing the combinations, and then you can put in numbers that aren't so easy. So you could do 22 plus 12 now. But they kind of get the concept of how to go up to another 10 plus another 2. And they can do that quickly in their heads. Okay? So I don't know, if you haven't done anything, just start them with the basics. Don't worry about starting too easy. That's a key. Okay?
That makes sense. So another question also. So a lot of people are actually confused, about the age at which to start. So Zaman Umair wants to know, what do you do for toddlers? And there were other questions on, what do you do for 4-year-olds? What do you do for 3-year-olds? What is the right age? So can you also talk a little bit about the exercise you just made me do? What age is that for? And I remember you telling me that your kindergarten kids do complicated patterns like AB and AAB and those kind of patterns. So at what age do we start making them think mentally for mathematics? Because in Pakistan, how they begin is the formation of the letters, the formation of the numbers, and then the spellings of the number names and patterns. That's how we begin. We don't begin with mental maths at all.
That's too bad, because basically you are starting with mental math just by counting. What comes after 2? 3. And so even as they're walking, 1, 2, 3, or, even I remember as a small child, 2, 4, 6, 8, don't forget to shut the gate. And then I did something with the kindergartens, 8, 6, 4, 2, don't forget to stomp your shoe or something like that. Okay. And so you can do rhymes, and it's like music. It sticks in your brain. Music sticks. So you can start at a young age just by introducing numbers as part of their life. And so, and even the identification of 2 objects. So there's 2. There's 3. So you just start that. That's even mentally starting to do the mathematics, so that numbers are part of their life from the beginning. It's not something new that's all of a sudden being introduced to their lives. It is something that's already part, and it's not a major deal then anymore. And if you did start, you know, like I say, 2, 4, 6, 8, and then you can go a little bit larger. Kids memorize things. They've memorized a whole bunch of words when they're young. Why couldn't they memorize some of these patterns when they're young? It doesn't mean that you're on them all the time and say, no, memorize, now memorize. No, it's just part of your life. Let's count these. Can you please take out 3? Can you please take out 10 of these for me? So they learn to count. That is very useful. And so you count with them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm going to emphasize this because I've had a number of experiences in Pakistan with adults who have not been educated. And with the adults who haven't been educated, they've been educated to a couple of grades, but when I've asked them to count for inventory purposes, they've really been challenged. And they'll give me like a stack of papers, and they'll say, this is 60 sets, that's 60 sets. And then they give me another stack, and that is 16 sets. That doesn't make sense, the 16. And so even that, just get your kids to do that in a young age. Sorry, I went on a little bit there, but it's not about, should I start them here or there? If you haven't done anything and they're 7 years old, get going.
Yeah. Okay, makes sense. Okay, we have a really interesting question from Beenish Salman, which is probably a problem that a lot of parents face. So she's saying, my daughter is so afraid of maths, and she wants to do sums with her own difficult way of counting fingers. She doesn't listen to me for mental work. Can you suggest what to do? And her daughter is 9, Beenish Salman's daughter.
Yeah. Okay. I would start with this again, what I just showed you. Get her to do some simple ones. This is what we're doing for our mental math program that we've just started. Actually, we started it this week for kids. It's just a simple half-hour program. And in this simple half-hour program, we start with this with the kids. And each week we're doing it for, I think it's 6 weeks at a time, or 8 weeks, 8-week sessions that we've just started for kids because of this concern. And it is, we just go back to the basics for the kids, and then we build them up quickly. She has to feel at least successful in some basics. And she might say to you, oh, this is too easy. You want to hear that. If it is too easy, great. Now let's go up to the next level. But don't just jump and say, now we have to go and do these ones really high. She's got to understand this complement that go to tens, and it makes it super easy. So like, for example, I said, how do you teach 2-digit subtraction is one of the questions here, like 27 minus 19.
Yeah.
And if they understand the numbers, what makes even up to 10, then like this is something else that we can talk about another time, is, going from, 27 minus 19, many people are looking at the algorithm, and I have to cross off, and then I have to, borrow 1 from the 2 to, and then subtract, and so on. So the easier way for kids, if they understood this, is if you said, well, let's go from, that's the same as saying 19 to 27. What's the difference? And so if we're going to do that, if you go up from 19 to 20, that's 1, plus 20 to 27 is another 7. So you've got 8, because 7 plus 1 is 8. And so it's that carryover I would get later. I would get, first of all, that add-on concept so they can see that. And then you can, that's a procedure. And to teach 2-digit subtraction, that's a whole other procedure. That's different from mental math. Okay? So, and teaching procedures and getting them to memorize procedures, all that is doing one after another, and constantly doing it, and then adding on and making it a little bit more difficult each time. And then you add more digits. And the more digits you add, the more practice they have for one number. And that's the way I would do it. Start with very simple, and then you keep adding on the digits, and you've got a child who can do the procedure well. If you want them to understand how to go from 19 to 27 and how to calculate that in their heads, I would start from 19, go up to the 27. It's 1 up to 20, and another 7 is 8. And that the answer is 8. Okay.
Okay. Yeah, that makes a lot of sense. Okay, we have a question from Abira, which is there a smarter way to teach your child division in mental maths? So I don't know if she's asking for like tricks. I don't know.
Okay.
Are there tricks?
Um,
I would like to know these tricks.
there's always little tricks. And it's not just about tricks, but let's just think about this for a minute, because again, that's a lot. I'm not too sure if they're talking about short division, whether they're talking about long division. Again, I think one of the keys for division is if kids don't have the automaticity in their number facts for multiplication, then doing division is really tough. And division, long division of large numbers requires a lot of estimation. So you have to know your multiplication facts. And again, this is why we do a lot of work in our mental math program on developing those facts and doing drills, so that the drills form the automaticity. Then you can get to the other types of mental math after that.
Okay. That makes a lot of sense. Okay, we have an interesting question from Anahita Momtazian. Her daughter is 11 years old and is a top student overall. She's even been registered for Spirit of Maths for some improvement. And she keeps telling her that this program gives her stress, as in the whole program. Okay, so this is not about mental maths, but the whole program of Spirit of Maths is above her ability. And what do you suggest? I don't want her to give up on Spirit of Maths. You know what I realized with the Spirit of Maths program? That it initially seems really hard, but then the kids suddenly get it. Like, at least that's what happened with my kids. And then they loved it. But initially, like, there was a little bit of ahil, like being like, oh my God, this is also because he was being taught by foreign teachers and he's always been taught by Pakistani. So with him, and Zoom isn't as much fun as in person. But I saw that with him. So initially, like the first 2-3 days, he was really like, oh my God, I'm dying. But then I don't know what happens, but he suddenly got it. Same thing with Rania. Like initially she was like, I'm not getting this. Suddenly she got it. So
Yes.
I don't know, like a day when. But what is your answer to Anahita's question? And also, talking generally, is it a good idea to put children in programs that are above their ability, or should we always look for programs that are at their ability?
Personally, I think that most people are able to stretch. And so you've got to look at their child. Don't just say, well, this is grade 6, and so I want to put my child's in grade 5, I'm going to put them in grade 6 just because of that. Look at the program itself. What kind of stretch are you giving them? You can't give them too big of a stretch. So you have to look at your child and see what's needed. To stretch a bit is always good, because kids learn how to deal with that and how to work through it. And they know not to give up and not to get scared. And it's okay that you don't know everything to begin with. Oftentimes, and I think we have to go back to the way our brain works. Our brain will adjust and will evolve to what we expose it to. So if you do not expose it to something that's going to help it evolve to a higher level, it's just not going to evolve necessarily to that level on its own very easily or very quickly. All right, so that's the one thing. Now, your child who is 11 years old, yes, in some cases, it takes 3 to 4 months before a child feels comfortable with Spirit of Math. And it takes a lot of work because they're not used to it. They're not used to the complexity that we introduce to the kids. This is a whole new way. Their brain is having to rewire itself to try and figure out things. The thing I would do is keep up with her, like do it more. Don't just come to class and just do it there, or just once a week do the homework. Do a little bit each day, so that the new type of thinking, it becomes norm. All right. And it's a way to it's a way to think. It's a way to reason that is very, very different. And it can be really tough for some kids to begin with. We often find that those kids, we can have kids come into our classes who are quite weak to begin with. And then what happens is they are working like crazy. And if they're working like crazy every week, all of a sudden they become the top of the class, and then everything becomes a lot easier. But there is a growth time, and it's a tough time, and to expect that tough time, but get through it, and you'll find that poof, all of a sudden everything will be there. The other thing to remember about the brain and the learning curve, like I always say this, learning curve is not going up like that. A learning curve goes like this. It's sort of a whole bunch of ups and then plateaus and ups and plateaus. That plateau time where it's often chaos and little bit of, oh, this is really stressful, is actually when your brain is building new neural networks. And so in your brain, it's like, oh, it's actually having to create new cells, dendrites that will join to each other so it can do this complexity of thinking. Once, and it takes a while, and that's why it's like, oh, because your brain is doing that. All of a sudden, once they're all joined up in a proper order, boom, up you go. And then you get to a higher complexity, and so your brain has to rewire again. And then boom, up you go. So some kids, if they're coming into Spirit of Math, that gap is larger, and so there's more for the brain to have to put together before it gets a lot easier, and then up they go. Okay? I don't know if I went on too much or that explained. Do you think I answered?
Yes. Yes, I think so, for sure. Yeah. Yeah.
Thank you.
Okay, so Anaita is actually saying it's very encouraging for her to hear that.
Yeah. Okay, good. Thank you.
So Zainab Khan wants to know that when is it the right age to start introducing patterns to children?
Oh, from a very young age. You can always show them patterns, even simple 1 2 1 2 pattern of skipping one. I don't know. As soon as they can start seeing it and they can talk about it, I would start looking at patterns from a very, very young age. It's amazing what they can do at a young age. Yeah. So I just soon as soon as they're identifying things, you say, oh, where's the next one? And can you find that? And just get them thinking right from a young age so it becomes norm.
Okay.
So I just wanted to touch upon one of the ideas that said here about written methods sustain more, and from Beanish. And yes, when you write, there's actually a lot of research that's showing that as we write, and this is why they're saying they're quite concerned about computer usage, if we actually do the handwriting, that the brain does actually retain a lot more. And there's some they've shown this research after research, and I just read some new research. It just recently came out again proving that. So when you are like doing the mental math comes after, and you've got to have that writing at some point and that consolidating. So when we do mental math, it's just basically the starts, and then we give them all these equations. And you talked about, is it only mentally in here so that you only hear it? It's actually no. When you see numbers written down, it should be that they're seeing the patterns and they're able to calculate and they're able to write things down easier. Writing is critical. It's absolutely critical. The other thing about writing, and I often talk to kids about this, is when you write, you're actually forming an image in your brain. So if you're going to write sloppily, and even your script is sloppy, it forms an image that isn't so clear for your brain. So you want to write well so that that image stays in there very clearly. And then you also want to write so that it's organized well. Because again, that organization of that information to make a bigger idea, if it's organized, it will stay in your brain in a better organized manner, and you're probably going to make more use of it. So writing is critical. Thank you, Beanish, for saying that.
We also have a question about board games from Shosha L. She wants to know that do you recommend any board games that will help their kids with maths? Because I think most kids don't want, and it also becomes exhausting for the mom to just sit down with the kids all the time and make them do it. So, are there any video games, or are there any like online drills so that the kid can do it? Or what about, like, I think there's one that HSN uses a lot called Hit the Button. I don't know if you recommend it or if it's a
I
popular
don't
one.
know it. I don't know that one. Maybe you can talk
I
about
don't
it.
know if you like get the right answer, like hit the button. It's not like it's too simple, I feel, when I've tried it. Like it's literally like change the sticks and it will hit the button. And right.
I know. You know what? We are this close to giving out our new drill app, and that will actually, that's an online, and you can go in and do those drills so that the kids, you could just say, okay, 5 minutes do your drill, and just that every day will make a massive difference. But it's not a game with other people. It's just trying to improve yourself and get to that level pretty quickly. So it's a personal game that you would do, an individual game. And that would get the tables up, and that would improve the automaticity of the number facts for tables. Now, other games, I don't know. I'm sorry, I don't know.
Somebody is recommending a board game called
Oh,
Rummy Cup. Rummy Cup. I don't know that game. Do you know that game, Kim?
Remy, I forgot about that for a while. Yes, it does. There's a lot of board games where it's just you have to add up even the numbers on the on some dice, and that gets the kids calculating quickly. If they're playing it enough times, they'll start to see the patterns. So yeah, thank you.
So Safa Khan has a question. She wants to know, how long does it take for all this effort that mothers make with children on reinforcing mental maths? How long does it take for this reinforcement to actually show some results?
Well, we find when we're actually introducing these ideas at like from the foundation, from what I just showed, you will see results the next lesson.
Really?
Oh yeah. Like there's just no question. It's the next lesson. If you're doing it with understanding first, then the kids will memorize it and off they go. I can remember once going into a classroom, this is in Winnipeg, and the teacher said to me, Kim, these children, like these 3 kids are so weak. They're not catching on at all. They're not able to even enter into our drills that they were using. And so I sat down with these 3 kids who were actually, they were classified as having disabilities of different types. And I just literally went through this exercise with them, had them memorize it, and clapped, 1, 9, 2, 8. We marched around the room. And one of the kids afterwards said, I can't get this out of my brain. It's now in there, stuck. And I said, well, that's good. But then from there, we were able to go very quickly to the other things, because now the kids had that proper anchor. They had something to work with. It's when you don't have something to work with and you're trying to get them to do something up here, they don't even have this, they're going to fall apart. That's where stress happens. So, so it should be that you see something immediately if it is done quickly. Now, it may be something minor, but you add on to that and you will see ramifications that explode afterwards. If you don't do it properly, you will not see any results. Okay.
Okay. That makes sense.
I haven't heard it at the box. There you go. Okay, thank you.
I wish these games were like available in Pakistan. I've never heard of them. Shut the box, I haven't heard of. Okay, there was a question about we've done Benish's question. There was a question from, I think it was Zainab. Yeah, this one. What's the role? Because we've spoken a lot about mental maths in children, mental maths in toddlers, but what about mental maths in teenagers? Like when we talk about advanced levels, like, I know so many kids right now who like totally stressing out about the SAT because since they didn't have O levels and they might not have A levels, so the SAT grade suddenly counts for so much more. So when you're talking about those exams like the PSATs, the SATs, etc., how important is it to keep brushing up on mental?
They need to know their basic facts. They will have difficulty with any of those tests because they won't be able to move fast enough, like the pace that's needed to get through all those questions. They may have an understanding, but you've got to have that. And this is again, if your child, I'm working with some grade 8 students, for example, right now, and just giving them our drills alone has made a massive difference for them to be able to do the math that's required for these tests. So it is critically important that you go back, you have a way for them to do drills. Like I said, I wish we had our drill app there because we're that close. And even just to get them to do 10 minutes twice a week, it gets that fluency up so that they can get to these questions a lot faster. It really is important to get these facts going. Again, you don't have to do the great big calculations, but there are certain things they need to know for the advanced, for the upper level kids. Another thing, like you should know your multiplication facts, your addition facts, so that there you can subtract and you can also divide. All of those will really help. Other things that we have found that what we work on with our own students is they have to also know all the decimal equivalents and to fraction equivalents from 1/2, which is 0.5, all the way up to 11/12. So they have to know 1/2, 1/3, 2/3, 1/4, 2/4, 3/4, 1/5, 2/5, 3/5, and so on, all the way up. And they will see the patterns and they'll know it. So if we give them something and something's on that on the sheet of paper, they'll know right away, oh, I know what that is. So if they're given, for example, 0.142856 all repeating, they know right away that's 1/7. Now the question becomes a lot easier, and they're able to do a lot more. And sometimes that's given as a percent question, and so if you write it as a fraction, you get it. And those are the types of things the fraction button usually doesn't give, or calculators don't give. If you have a decimal, it usually doesn't get the fraction. Now, I know a couple of new calculators are out that can do that, but to not have to stop here and go to your calculator and just to know some of these basics are important. So we do that. The other thing that we do are perfect squares. Because again, recognizing the perfect squares and recognizing a number is a perfect square often makes the mathematics a lot easier. So we have our students memorize perfect squares from 1 squared all the way up to 60 squared. That is 60. And it sounds crazy, but there's a lot of patterns that are happening. And so the kids are memorizing the patterns, and so then they can do those squares pretty quickly. And they can recognize the numbers that are the squares. Another one for the senior grades, which you may want to look at, is radian to degree measure, and make sure they have those as automatic and they're memorizing those. And I think we did something else too with calculus. I'm trying to think of what the calculus one was, but there's always something to memorize in every grade that will help you get better. Okay.
Yeah. Great. Okay, Abira wants to know, Abira has a couple of questions. So the first question is, how do you give the concept of approximation to a 10-year-old, which is grade 5? And then she has a completely different question. So maybe, I don't know if I can do it right now. Should I bring up the questions because they're not linked?
Okay, so sometimes when you're doing approximation, it's often taught to the rules. So the kids have to know basic rules. Like if you have 2.6, that's approximately 3. Okay, if they want to approximate it to the units, to the whole number. If you had 32.7, that's approximately 33. So they have to know the basic rules. And once they know those basic rules, then it's the application. So sometimes what happens when kids you're giving them all these rules. They don't necessarily remember them because they haven't used them in an application. So use it right away. Get it? So you might want to do, if I'm going to approximate 2.6 into 32, what would that be? Well, if first of all, they should know the multiplication facts. If they don't know it, they're going to get really frustrated because that approximation will be too tough. So I said, what, 2.7 into 32? You could approximate, go up to 3. And now 3 into 32. If they have their multiplication facts, 3 times 10 is 30. So it might be around 10. It might be 9 because it's a little less. Or, so that's how they can approximate. Start using it, applying it, see if they got it correct. And you just use it over and over again, the same numbers. Don't make it too complicated, too many different numbers. So they get that one first and then go on to the next one. So you could do 2.6 into 32, 2.6 into 64. That's double 32. 2.6 into 40. Do you think it'll be a little bit more? Like try and do little numbers like that, and then they'll start to get good because they're not changing the primary number. They're using that over and over again, so they're getting good with that one. Then you add in another number, and they'll start to apply the concepts they learned and the reasoning they learned the first time. So again, I'll go back to that idea that don't teach too many rules at once, because if you do, then they'll just start to memorize, and you've got all these little pieces that they're memorizing all over the place. It should become reasoning. If you teach one rule and you add on another one to it, then they can reason their way through it. Then they're adding on and they're building a foundation, not a whole bunch of little pieces of memory. Okay?
Okay. So I think we have time for, this is probably the last question from Beanish. She's saying, what about teaching our children how to learn numbers? Is that like a modern way of teaching maths or an old-fashioned conventional method?
It used to be old-fashioned, now it's back. Okay.
Fashion.
Yes. So it's fashionable. But it's not really fashionable. It is needed. They have to know at least up to 12 squared. They should know, those times tables so that they can apply it to bigger numbers. And if they just don't have that, it's sort of like not knowing that TH makes the th sound in English. And if you don't know that, you're not going to be able to read well. You're not going to be able to understand what's going on. So it's the same thing. They should know. They should know the basics. It's critical they have those times tables.
Great.
And that's just what I'm going to say really is what we focus on when we do our mental math courses. We actually focus in on that. And all we have to do is half an hour once a week with the kids, and you see, boom. And it really is critical for that basics. There are some other ideas out there where the kids are memorizing where beats go and so on, or other things. And that's not necessarily understanding numbers and memorizing the basic tables. That's just remembering a picture and therefore here's the answer. It's kind of cool. It is neat. You could teach the kids that. Make sure they've got the other concepts though, please, because otherwise they won't be able to enter into a lot of other mathematics.
Great.
Thank you, Bina.
Yes, the mothers love you. Well, thank you so much, Kim. Thank you so much. And also, Spirit of Maths is offering a mental maths course. Is that correct?
Yeah, we just started this week. Yes. And in fact, yesterday, was it this morning or yesterday morning, we actually have our time so that Pakistani children can also join at a time that is more appropriate for you. And so our teachers are waking up super early to get this. I know here in North America, they filled up like that. And so the grade 1, 2 classes, I think, are full for our timings. I think there still is space for your timings, but they filled up super quickly, and now we have waiting lists. So you may want to, I'm not trying to push things, it's just if this is a concern, we've really tried to make it so that the price point can be, people can enter into it from, if you're having financial difficulties too, it shouldn't be too difficult for you as well. Okay?
Absolutely. Thank you so much,
You're
Kim. It was amazing to have you again. Like always, a pleasure. And this was a really cool lecture with lots of practical tips for parents on how to help their children learn a skill. So, thank you so much. This was amazing.
Well, thank you again. And it's really nice getting all these questions and answering them. It helps us understand where your challenges are as parents and as educators, because if we can understand that more, then we can also help you better and we can be much more focused. So thank you.
Thank
Take care,
you.
Aisha.